So let's look at the first question off of the review sheet. It says the article Thriller states that surveys tell us more than half of America's college graduates are avid readers of mystery novels. Assume the true proportions exactly 50%. What's the probability that an SRS of 225 college grads would give a sample proportion greater than 60%? So first of all, I'm going to write the givens down right here, or highlight those things. It tells me clearly it's a proportion problem, and the true proportion is 50%. Then I have an SRS of 225 college graduates, and the question is, what's the probability that my sample proportion is greater than 0.60? It's probably worth pointing out that this value right here is a parameter. It's about the truth. This n is from a sample size, so this is a statistic, and this 60% goes with p hat, which is also a statistic. So I want to draw a sampling distribution, and I want to draw it as normal, but in order to draw it as normal, I have to check one of the rules of thumb. Namely, I have to check to see that NP is bigger than 10 and N times 1 minus P is bigger than 10. This is telling me that my sampling size is large enough to allow the sampling distribution to be approximately normal. So I have 225 people, 50%, and 225 people, 1 minus 50%. In both cases, 112.5 is greater than 10. And therefore, I know the sampling distribution is approximately normal. And so I've drawn it as such. Now, furthermore, I know that since it is an SRS, I have an unbiased estimator of the middle. So I know that this is telling me that the mean of all of the p hats is going to be the same as p, and therefore this value right here is 50%. And finally, I need to come up with something to get the standard deviation, to get this distance right here. And the standard deviation goes with a different rule of thumb. Namely, since there are certainly more than 10 times 225 college graduates, the standard deviation of all the p hats is going to be the square root of p times 1 minus p over n, or in this case, that's the square root of 0.5 times 0.5 over 225. And so that is my standard deviation, and so I can write that right here, the square root of 0.5 times 0.5 over 225. And if you want to work that out and figure out exactly what value that is, then that's okay to put in there. I prefer to write it like this. Now it's simply a matter of taking this, standardizing it according to this mean and standard deviation, and going from there. So now I have the probability Z is greater than 0.6 minus 0.5 over the square root of 0.5 times 1 minus 0.5 over 225. That's the same as Z is greater than 0.1 over the 0.03. It's about 0.03 right there. And that gives me Z is greater than 3, which I could look up on my chart or use my calculator to get that this shaded area here is 0.00135. Pretty small, 3 standard deviations above the mean up there, and that's the probability that a random sample of 225 would give me a proportion greater than 60%. Or put another way, if I had lots of people take samples of 225 random college graduates and ask them, do you like mystery novels? When the truth is 0.5, there's a very slim chance, 0.135% chance, that my sample has 60% or more.